This is the first lecture of Basic Electrical and Electronics Fundamentals. It is titled as Introduction to Electricity and Electrical Quantities, lectured by Turun Bodhikar. Understand the concept of electricity, define and explain voltage, current, resistance, power, energy, familiarize with standard electrical units, recognize basic measurement methods are the learning objectives of this lecture. Now, what is electricity? Electricity is the flow of electric charge, typically due to the movement of electrons in a conductor. Electrons move from negative to positive terminal through a conducting path. And we know the flow of current is in the opposite direction of flow of electrons. In real world, lighting system, household appliances, transportations, that is in mode of electric trains, EVs, are the examples of application of electricity. Now, charge is the fundamental property of matter, is measured in coulombs. Movement of electrons is equivalent to current. Electric current is the rate of flow of charge per unit time. Water flow in pipes can be considered is as equivalent of current flow in wells, whereas water pressure is equivalent to voltage. The diagram depicts water and electricity behave in similar ways. Here, the volume of water is equivalent to the charge in coulombs, and the friction loss in the pipe is equivalent to the resistance in ohms, and the flow of water is equivalent to current in amperes, and the pressure difference is equivalent to the voltage in volts. Now, what is voltage? The work done to move a unit charge between 2 points in an electric field is known as voltage or potential difference. It is symbolized by capital letter V, and its unit is volt, which is symbolized by capital V. The voltage of AA battery we can express by 1.5 volt. And similar way, the household supply can be expressed as 30 volt AC in India. Now, what is electric current? Rate of flow of electric charge in a circuit is known as electric current. It is symbolized by capital I, and the unit of electric current is ampere. There are two types of electric current. One is direct current, which has constant magnitude and direction. On the other hand, alternating current, that is AC, varies in magnitude and reverses direction periodically. The two diagrams, the first one shows the alternating current and the second one shows the direct current. In alternating current, the magnitude and the direction is continuously changing with the time, whereas in the second diagram, the magnitude of the current and the direction is fixed in respect of time. Now come to the definition of resistance. Resistance can be defined as the opposition to the flow of electric current in a conductor. It is symbolized by capital R and its units is ohm. Bulb filament is an example of resistance which has a high resistance. That is why it generates heat as well as light. And another example of resistance is fixed resistors in electronic circuits. The diagrams are showing the symbol of resistor as well as the physical diagram of resistor. These are two physical representation of resistor, and the above two are the symbol of resistor. Ohm's law is an important law in electricity. It is a fundamental law. It states that the current flowing through a conductor is directly proportional to the applied voltage and inversely proportional to resistance when other physical conditions remain unchanged. It can be expressed by the equation V equal to IR, where V is the voltage, I is the current, and R is the resistance. The relation in between VI and R is expressed by V equal to IR. From this equation, we can find out I equal to V by R, as well as we can find out R equal to V by R and V by I. And for an example, if a 12-volt battery connected to 6 ohm resistor, what will be its current? Current I equal to V by R equal to 12 by 6 equal to 2 ampere. In this way, we can find out any one parameter if we know the other two parameters value. This diagram showing the direction of flow of current, positive to negative terminal. It is shown by the solid red arrow, clockwise arrow, positive terminal to negative terminal. Ammeter is connected in series in the circuit, and voltmeter is connected in parallel in this circuit. And this diagram shows the reverse direction of the current. It is happened by changing the polarity of battery connection. Here shows the battery connection minus plus, in first diagram plus minus. That is why the direction of current change, and it is in anti-clockwise direction. Here also ammeter is connected in series and voltmeter is connected in parallel to measure the current and voltage of the circuit. Let's discuss about the power. Rate at which electrical energy is consumed or converted into another form, that is in heat, light, motion, etc., is known as power. It is symbolized by capital P. and the power can be obtained by multiplying voltage and current, and the relation in between power, voltage, and current is expressed by the equation P equal to V into I. The unit of power is watt. We say 10-watt LED bulb, like as 60-watt ceiling fan, like as 100-watt heater coil, etc. in our daily life. Here is a table showing appliances and their real powers, reactive powers, and the power factor. Like a fluorescent lamp, real power 30, reactive power 69, and the power factor is 0.4. Now come to the energy. The capacity to perform work in electricity, it is the total power consumed over time, known as energy. Energy can be measured by multiplying power and time. It can be expressed in the equation E equal to P into T. The unit of energy is either joule or kilowatt hour. Household electricity bills are calculated in kilowatt hour. It means 1000 watt per hour. A 100-watt bulb running for 10 hours can consume 1 kilowatt hour. Kilowatt hour also represented by BOT, Board of Trade Unit. We have to pay the electricity bill by BOT unit, and so 1 BOT equal to 1 kilowatt, that is 1000 kilowatt per hour. Now, recapitulate the electrical units. The unit of voltage is volt, and the unit of current is ampere, and the unit of resistance is ohm. The unit of power is watt, and the unit of energy is joule or kilowatt hour. Volt is represented by capital V, ampere is represented by capital A, ohm is represented by the symbol of ohm, and watt is represented by capital W. Joule is represented by capital J, and kilowatt hour is represented by kWh. W is in capital letter, but K and H are in small letter. We used the unit of voltage to specify the batteries, supply line, etc., as well as load current in fan is expressed by the unit ampere, whereas the resistor, filament specifications are mentioned by the unit ohm. Bulb motor rating are specified by the unit watt, whereas electricity bill, in electricity bill we use BOT or kilowatt hour. The meter in our house to measure the consumption of electricity is an example of energy meter. It measures the electrical energy. Let's discuss about the measuring methods of electrical parameters. We have already discussed the basic parameters: voltage, current, resistance, power, energy. Voltage can be measured by voltmeter. It is connected in parallel to the circuit, and the current is measured by ammeter. It is connected in series connection. Multimeter is used to measure voltage, current, resistance, and it is an instrument which can measure voltage, current, resistance. The power is measured by wattmeter, and already I told energy is measured by energy meter. When we use the measuring instrument, we have to conscious about the range and settings of the instruments. Otherwise, the instrument may be damaged, as well as we can face electric shocks, shock, etc. Right? Now, the diagram is demonstrated the flow of electron from negative terminal to positive terminal by solid red arrow, and the conventional electric current flow is the opposite direction of the electron flow. Here, electron flows in anti-clockwise, so the current flow will be clockwise, positive to negative terminal. Switch is off, so bulb is off. If switch is in on condition, then the bulb will be blown. Okay. Now, some points to be noted for safety purpose. Use only low voltage batteries like 1.5 volt, 9 volt for demonstrations. Avoid contact with mains electricity to 30 volt in India. For America or other country, the main electricity voltage is different, but in India, 230 volt is the standard main electricity. Check wires for proper insulation before use. If there any damage, then we can get shock, electric shock through the leakage, which is dangerous to our health. So we have to conscious about the proper insulation before use. We have to check it first before use any instrument. Always connect instruments correctly to prevent damage. It is a mandatory safety point. We have to connect, we should have to connect always instrument correctly to prevent damage. Now, I am summarizing the points which have been discussed by me in this lecture. Electricity is the flow of charge, that is electrons or electric current. The key quantities are voltage, current, resistance, power, and energy. The unit of voltage is volt. The unit of current is ampere. The unit of resistance is ohm. And the unit of power is watt. Whereas the unit of energy either joule or kilowatt hour. We can measure the volt, that is voltage, by voltmeter. By ammeter, we measure current. We use multimeter for measuring voltage, current, resistance. We can measure power by wattmeter and energy by energy meter. Simple experiments help in understanding fundamentals, and the safety precautions I have discussed in this lecture. So this is the introduction to electricity and electrical quantities. Thank you.